Okay, welcome to Planet Geography. Today we're tackling two population theories that disagree with each other, Malthus and Boserup. So what I thought we'd do is we'd start with the similarities. Okay, both we can see a line graph. So they have time on the bottom, and then they have human population on our y-axis. The similarity we can see is that in both cases they see population growing exponentially. Okay, that is how they are similar. We are now going to look at, well, how are they different? Because what they predict is the complete opposite, okay? So let's jump into Malthus now. Okay, so let's break down Malthus. So before we understand his theory, let's just understand the graph. So here we've got time. Why it's a line graph is a bit of a timeline. And then on this one we have population. Okay? So, what did he say? As we know, Boserup and Malthus, they kind of agreed the population was growing exponentially. Now, exponentially means doubling. So 2, 4, 8, 16, 32, 64, 128, and so on. Okay? It's increasing exponentially. Now, that comes from high birth rates and lowering death rates. So this time in the UK, medicine was becoming kind of more scientific, but yet birth rates were still incredibly high. There were still traditional roles for women, a lack of female education, so birth rate was very high. Now, the issue that he saw on the horizon was that, yes, population is growing exponentially, but resource production, aka food, was growing arithmetically. Arithmetically might mean 1, 2, 3, 4, 5, 6. Okay? It wasn't growing exponentially, which is kind of doubling. And so he could see this future. And so what he saw is that whilst they were living in a period of abundance, where there was enough resources for the population, in future, it would move to scarcity, where there simply would not be enough resources. And this would lead to kind of something that he called the population trap. And he felt it was inevitable unless growth was controlled. And he said in this trap you would experience positive checks, which is kind of a weird way of saying population crashes. So what he would said, instead of it growing exponentially like so, once we reach the scarcity stage, we would say growth occurring like this, going up and down, and it could not be sustained, that exponential growth. Now, what did he mean by a check? Well, a check, for example, what caused this check? Well, it could have been a conflict. Two countries fighting over resources to feed their population leads to a population decrease. Okay? It could be a famine. There could be, this is a drought. Let's say there's a drought that takes place, an unusual weather event that causes the food chain to collapse. What happened here? Could be a disease, let's draw a disease like this. Like COVID, like Ebola, coming along and causing that check. So he was saying that we'll kind of have these Malthusian collapses, we called them, and they would essentially put a ceiling on what human population could be. Now, Malthus didn't just come up with this theory off the top of his head, he says it's kind of obvious, but in reality, he studied lots of examples from nature. Now, the example he used from nature was rabbits. Okay, when he found that rabbits can breed very, very quickly. Okay, here's my terrible rabbit. And so their population would boom. And then they would proliferate so much that eventually the food source would run out and the rabbit population would collapse. The language he actually used was, what did he say? He said, it would be a mass die-off. And he kind of said that these checks that we were experiencing in humanity were demonstrated through mass die-offs in nature. This was pre-evolution, and actually Darwin took this and used it to further his understanding and theory of natural selection. Okay, so this is the Malthus theory. Understand that exponential growth. You can also say, you don't have to say arithmetically, you can say linear growth. I think that's a bit easier in terms of our language. And this causes population checks such as war, famine, and diseases. Okay, so it was quite a pessimistic view of reality. All right, this was really only at the start of the Industrial Revolution was he writing this theory. Okay, so he hadn't seen the wonders of technology and what they could achieve. So this was his theory, and again, like I say, it talked about population collapses. We're now going to look at Boserup, who comes up with a different theory that kind of argues against what Malthus is saying. Okay, so I've recycled this graph. We still have time and we still have population. Again, Esther Boserup did not disagree with Malthus when she said that population would grow exponentially. They were both very much in agreement with that. But Esther Boserup's theory was much more optimistic, okay? She believed that there was, not so much of a need to be so alarmist, such concern. And she believed that resources could also grow exponentially. And every time it got to this crisis point where scarcity was just about to be experienced, humans would innovate. And what does innovate mean? Well, innovate means improving technologies, okay? Inventing new technologies. And her famous expression was that necessity is the mother of invention. And it kind of says humans are at their best when they have to be. And we kind of see that. The night before the exam, you are 10 times more productive than you are 6 weeks before the exam, okay? And so every time we get to this point where we're almost in crisis, humans will find technology to increase production, okay? Increase resources. Now, this theory is mainly about food, but an example that you've lived through would be the COVID pandemic. Usually it takes 10 years to create a vaccine, and humanity made that vaccine in 9 months. And they did it because they absolutely have to, and it proves her theory that necessity, when you have to do something, that is the mother of invention, okay? So, what were these inventions? If you look, it could be irrigation, improvements in irrigation. Okay, irrigation is moving water to fields. It could be the invention of plows pulled by animals and oxes. Then it could be the invention of tractors. Okay, thinking a tractor can do 10 times the work of an animal. Okay, what comes next? Maybe it's the invention of fertilizers and then genetically modified crops. Every time that we need to, and here could be AI farmers. Every time we need to produce more resources to stop scarcity, we would do this. And so she did not believe that there would be any checks. There would be no downward motion. There would be no negative checks like war, famine, and disease, okay? She believed that technology was the answer. And this kind of makes sense because she was kind of much more born into the Industrial Revolution. And she was at a time where technology had kind of proven itself. And who has been proven right? Well, currently, as it stands, you would say, well, Boserup's theory is been proven right. We haven't had mass famine. We haven't had the loss of 200 million people due to a famine or diseases or a lack of food. However, the counter argument is that, okay, technology is great, but Earth can only produce so much. We can't keep saying, okay, well, technology will allow us to produce even more. We only have one planet. So eventually, we will have just maximized our planet. We only have one planet, and eventually technology will have gotten everything it can out of it. And so climate change is a big example of this. You know, are we reaching the point where we simply can't get any more out of our planet, and we'll have a population collapse? So the idea is one right, is one wrong? Well, time will tell. You know, 100 years from now, there may be a population collapse. Generally, though, it is predicted that population will plateau, and by the end of this century, it will actually start to decrease. And if that is the case, then I think at that point, we can say Malthus was incorrect and Boserup was correct. But who knows? Climate change might cause something like this to take place. Yep, a Malthusian catastrophe. So, I hope that helps. We'll find an example.